Guys, let us start induction motor. So we are left with here induction motor, three-phase induction motor में no load test and block rotor test. So let me do that here. No load test में here. Make sure that you don't load on the motor something like sump में पानी नहीं है, but you switched on the motor, induction motor को पानी ऊपर pump नहीं कर रही. That's under no load. So what will happen here now in that case? For example, this is induction motor and we have three-phase supply. So what I do here, I'll connect a wattmeter, same as what we have done in case of transformer. Single phase, लेकिन ये वाला three phase है. Three phase में 3 wattmeter method है or 2 wattmeter method to measure the three phase power. So what I am doing here now, wattmeter MCLV, ये वाला एक wattmeter है, इधर एक MC, ठीक है, and this one is kind of MNC short circuited. This is B, DL is here. So this is three-phase supply and करना क्या, एक ammeter भी रखना चाहिए. Normally we keep 3 ammeters, we'll take the average and voltmeter here now. क्या करेंगे इधर, इंडक्शन मोटर को सप्लाई दे रहा हूँ तो पावर मेजरमेंट के लिए 3-phase पावर है, ठीक है, दोनों पावर मिल जाएगा. पावर इज P1 plus P2. Can you please mute yourself, guys? So 3-phase power है, दोनों पावर ऐड करना, but make sure that you increase the voltage until rated voltage is obtained. V0, ठीक है, current I0. And power is, you can say P0. As you can say P0, which is P1 plus P2. So हमको क्या मिला, voltage मिला, current मिला, power मिला, no load test, same as a transformer. इसका equivalent circuit क्या हो गया, transformer under no load, we keep only the shunt elements, series elements को neglect कर दिया. लेकिन इधर क्या होगा, we can't neglect the series elements. We can't neglect the series elements here. क्योंकि 30% 40% no load current में जा रहा है, so drop होगा. इसलिए what is the equivalent circuit here now? Equivalent circuit of this induction motor when it is running under no load, unlike your transformer, it has series elements also. Rated voltage तक आया, so what is the voltage? V0 है ना, V0 line voltage. I'll make it a per phase voltage, V0 by root R1 JX1. So this is JXM, this is RI, and then R2 dash by S. Now this is the equivalent one. What I do here now, ये दोनों को parallel में करो. So I'll have something like R1 JX1 here, and this is JXM, and this one I called RIFW, which is RI and parallel with R2 dash by S. So अभी इसमें voltage V naught by root 3I, current is I naught, करंट मिला ना. तो हमारा एम क्या है? एम इज टू फाइंड बाय डूइंग ए नो लोड टेस्ट एंड ब्लॉक रोटर टेस्ट. एक और टेस्ट है. We need to find the equivalent circuit of induction motor. So what I do here now, this is the first one, second. So what I make it here now, R1 JX1 series, ये दोनों parallel है. Can't I make it Z equivalent here now? Z0. If I say Z equivalent or Z0, something like here now, what is the Z equivalent here? ये दोनों parallel है in series with this R1 plus JX1 plus RIFW parallel with JXM, I would say. अगर मान लो आपने कर दिया यार, Z0 मिला आपको, something like you got R0 and X0. Z0 कैलकुलेट कर दिया, आप ये सिंप्लीफाई कर दिया तो रियल टर्म आएगा, इमेजिनरी टर्म आएगा. Say just I am representing here now. This is V0 by root 3, current I0, total equivalent. I am making this as a R0 and ZX0. How can you obtain this? So look at here now, the loss P0, which is equal to series element है ना. So 3I square I0 square R0. So आपको R0 मिल जाएगा from this expression. R0 मिल जाएगा. Then Z0. I can obtain Z0 is V0 by root 3 and I0. Z0 मिल जाएगा. X0 चाहिए. X0 is Z0. Z0 square or not square. So what we have obtained here now, by knowing these three values, V0, I0, P0, हमको पता चला R0 and X0 पता चल गया यार अभी. लेकिन R0, X0 क्या है इधर? R0, X0 are not the actual values of induction motor. ठीक है, actual values of induction motor are R1, X1, XM, RAW. So इसमें क्या होता है? R0, X0 मिला, इसको कन्वर्ट करना पड़ेगा. What is the actual values of R0 in terms of this thing? What is the actual X0 in terms of this? So दो expressions आना चाहिए. Two expressions I have got here are, simplify करके अब real and imaginary term करना है ना, मैं सीधा लिख रहा हूँ RFW XM square R0 minus R1. दूसरा expression क्या है for this X0? XM equal to X0 minus X1. So एक expression R0 के लिए ये, X0 के लिए ये expression है. मिला यार. लेकिन क्या प्रॉब्लम क्या है इधर? प्रॉब्लम क्या है ये देखो, हमको पता है R0 and X0 वैल्यूज पता है, लेकिन हमको चाहिए इक्विवेलेंट सर्किट ऑफ इंडक्शन मोटर X1, XM, RIFW, ये वैल्यूज चाहिए. कैसे पता चलेगा? देखो, I know the R0, okay, I know the R1. R1 can be calculated by DC test. ये वाला सेपरेट है, you also know this. लेकिन ये दोनों पता नहीं है. ठीक है, इधर आओ, ये वाला एक्सप्रेशन है. X0 पता नहीं, X1 is unknown. Once you know the X1, I can calculate XM. तो कौन सा वैल्यू हमने कैलकुलेट कर दिया यार? Not even a single value we calculated here now इंडक्शन मोटर में. हमको चाहिए X1 चाहिए, X1 नहीं मिल रहे. XM चाहिए, XM के लिए X1 चाहिए. तो कोई एलिमेंट नहीं मिल रहे, कैलकुलेट नहीं कर सकता हूँ इधर नो लोड टेस्ट में. लेकिन इक्वेशंस मिला. जब आपको X1 मिलेगा तभी आप XM को कैलकुलेट कर सकते हैं. So what you need to do, X1 को कैलकुलेट करना कैसे करेगा? For that we need to do the another test here now, which is called block rotor test. Unlike the transformer में क्या किया है? ट्रांसफार्मर में OC टेस्ट कर दिया तो नो लोड टेस्ट कर दिया तो शंट एलिमेंट्स मिल रहे. इधर नो लोड टेस्ट कर दिया तो कुछ नहीं मिल रही. No test, no value is obtained here now. We are waiting for the x1 value. ये वाला x1 value मिलेगा हमको इन ब्लॉक और रोटर टेस्ट में मिल जाएगा. ठीक है, please mention that point. Unlike the transformer OC test, unlike the transformer OC test or no load test, with just no load test data, shunt elements cannot be calculated. Shunt elements cannot be calculated. Okay. To calculate shunt elements, x1 value is needed. X1 to calculate shunt elements, x1 value is needed. Which can be obtained from x1 value is needed, which can be obtained from BR test, block or rotor test. Which can be obtained from BR test, block or rotor test. So why did we ignore this one here? Why x2 dash को ignore कर दिया मैंने? Normally x2 dash होता है ना? Why the x2 dash ignore? Because R2 by S no load में है ना? High speed में जाएगा मतलब S is very low value. So R2 dash is pretty much greater than x2 dash. So x2 dash is neglected. Can mention that point. X2 dash is ignored because R2 by S is higher under no load test. Okay, now block और rotor test करना है. Next test is SC test. SC test equivalent क्या है? Block or rotor test. This is BR test. This is equivalent to short circuit test in transformer. Equivalent to short circuit test in transformer. What are we doing here now? Same as a previous one experimental setup. करना क्या? You don't allow the rotor to rotate here. मतलब rotor घूमेगा. Rotor will be rotating here now. You can see this now. One point. So see this one. When the rotor is rotating, you have a rotor. You hold the rotor. Hold the rotor. पकड़ लो. मतलब with the cutting blade or with external means, not with the hand. हाथ से मत पकड़ो. So hold this one. But the supply is on. Supply is on. But don't allow the rotor to rotate. तो क्या होगा यार? What will happen in this case here now? So if you do that, what is the speed? Speed is 0 here now. When you don't allow the rotor to rotate, speed becomes 0. And what will happen? Yes, S equal to 1 because S equal to, this is the value. N0 होगा NS minus S equal to 1. So what will happen here now? R2 by S. Previously during running condition, what will happen? During running condition, what is happen? R2 by S is high. क्योंकि S value 0.04 है ना? Around 0.04, this is high. Now this is R2. Blocked में value of R2. So during block, block or rotor, what is R2 by S equal to 1? So ये value R2 dash हो गया. ठीक है? When the rotor is not rotating, the resistance of the rotor is very, very low. Meaning during block or rotor test, rotor resistance is value is less. Please mention that point. During block or rotor test, rotor resistance is R2 dash is less, hence equivalent to a short circuit test. Resistance कम है ना तो ज़्यादा करंट आएगा, लेकिन don't allow the more current to flow, just allow the rated current to flow. कैसे कर सकते यार? आप rated voltage मत apply करो, you apply some voltage such that short circuited rotor में अभी rated current जाएगा. उसके लिए हमने voltage कम करना पड़ेगा supply side. ठीक है? What is the equivalent circuit here now? So more current is going. Yes, I cannot neglect the series elements, but the voltage is less. So you can neglect if you want iron losses because voltage less है ना. Voltage less हो तो iron losses को neglect कर सकते हैं. So this R1 JX1 magnetized current cannot be neglected. So this is R2 dash S equal to 1 JX2 dash. And what is the voltage? Apply the voltage such that rated current is obtained. So I call the values. 3 values आ जाएगा ना here. Same voltage and current and the power PBR. So this one is rated current. So what is this represents here? ये वाला कौन सा losses represent करेगा? देखा इधर VBR equivalent circuit PBR by root 3. Current इसमें जाएगा IBR क्योंकि equivalent of induction motor है. R ये neglect कर दिया क्योंकि voltage कम है. So ये losses किसमें होगा? Losses होगा R1 and R2 में. Stator copper losses, rotor copper losses. So wattmeter measures stator and rotor copper losses, neglecting the iron losses. Because voltage is less, when the voltage is higher rated, iron losses rated मिलेगा, लेकिन इधर क्या rated voltage नहीं है, कम voltage में आपको rated current मिल जाएगा क्योंकि ये वाला short circuit है, rotor resistance कम हो गया अभी than the running condition. So now again the same thing, I can make this one is equivalent to what I'm doing here now. इसको equivalent डालो, something like same scenario previously what I have done. PBR by root 3, current is IBR. ये वाला है ना, ये दोनों series है, parallel है. So what I am doing is RBR JXBR. So what it means is ZBR which is equal to RBR plus JXBR is ये वाला equivalent है. ये दोनों parallel है. Parallel JXM plus in series with this. So आपको ये वाला रियल टर्म इमेजिनरी टर्म अगर आपने कर दिया, कंपेयर कर दिया, इसको रियल एंड इमेजिनरी टर्म को आरबीआर एक्सबीआर मिल जाएगा. So what are those RBR and XBR values here now and how to calculate that? RBR and XBR values are comparing these two. I get the two expressions x1 plus x2 dash XBR, XBR का value and RBR का value क्या है? RBR का value R1 plus R2 dash which is equal to RBR. And most of the time this will be equal. So what we do here now, so rather than saying equal, x1 equal to x2 dash which is equal to XBR by 2. That's approximation we do. x1 equal to x2 dash is equal to XBR 2. Another one is R1 plus R2 dash equal to RBR here now. ठीक है यार, RBR XBR कैसे आएगा? इधर से मिल जाएगा. How can I obtain? From here now, PBR which is equal to ये वाला 3 phase power है ना, 3 times IBR 3 square RBR. So RBR can be obtained PBR by same as the previous one, whatever we have done. So ZBR is PBR by root 3 P by I. So then XBR can be obtained. So this is how we can obtain the X value. So basically, once you obtain the RBR, XBR from this, you substitute here, get me the values of here. So इधर हमने नो लोड में क्या है, कौन सा वैल्यू के लिए मैं वेट कर रहा हूँ यार, नो लोड में x1 का वैल्यू के लिए वेट कर रहा हूँ. देखा x1 मिलेगा which is xbr by 2, xbr मिलेगा, इधर से मिलेगा xbr. सो आप x1 कैलकुलेट करो, नो लोड का डेटा में सब्स्टिट्यूट करो, आपको xm मिलेगा, xm मिलने के बाद RIFW मिलेगा. सो बोथ शंट एलिमेंट्स मिलेगा. इधर सीरीज एलिमेंट्स क्या है, x1 x2 डैश दोनों मिल जाएगा, ठीक है, एंड R2 डैश में मिल जाएगा आपको. सो ऑल शंट एंड सीरीज एलिमेंट्स आर by doing the both the test, no load and block rotor test. By doing the both the test, we can obtain the series and the shunt elements of the induction motor. That's what I was saying. Just copy this one. So unlike transformer में इधर में क्या फर्क है, ट्रांसफार्मर में आप में अलग अलग शंट एलिमेंट्स अलग मिलेगा आपको, नो लोड टेस्ट कर दिया तो सीरीज एलिमेंट्स अलग मिलेगा, आपने एससी टेस्ट को कर दिया. लेकिन इधर क्या होगा, दोनों टेस्ट का डेटा चाहिए आपको इक्विवेलेंट सर्किट ऑफ इंडक्शन मोटर के लिए. समझिए ये बात. सो प्लीज कॉपी दिस. One more thing here now, since voltage has reduced, definitely SC test in a voltage has reduced, frequency has to be reduced accordingly. V by F should be constant. मैंने बता दिया ट्रांसफार्मर में V by F constant रखना चाहिए फ्लक्स डेंसिटी constant के लिए, ठीक है. इधर भी वही करना चाहिए, वोल्टेज कम कर दिया इधर, सो उसके हिसाब से फ्रीक्वेंसी भी, सप्लाई फ्रीक्वेंसी भी कम करना चाहिए, ताकि आपका V by F रेशियो कांस्टेंट होगा एंड फ्लक्स डेंसिटी कांस्टेंट होगा मशीन, ठीक है. Note that point, please mention that point. Since BR test is operated at low voltage, frequency should be reduced, supply frequency should be reduced such that V by F is constant. Supply frequency should be reduced such that V by F is constant. Okay. Okay, Bhaskar. Next one is starting of induction motor. How does the induction motor starts? Starting of induction motor. So you see that question in 3 idiots. The same question is here. How does the induction motor starts? So anyway, starting of induction motor, हमने DC motor का starting देखा है. We have seen the DC motor starting. That is a starting current is high, DC motor. And we have seen the starting of synchronous motor. Synchronous motor is not self-starting. It required a kind of auxiliary motor, or we need to have some damper winding, right, or Ramasher's winding for starting of synchronous motor. And now the starting of induction motor. Starting of induction motor, yes, this is a self-starting. Unlike your induction, unlike your synchronous motor, this one is a self-starting motor. Okay, then what happens? What is the problem here? Now let us see. So what is happening here now? Starting of induction motor में, let us see during starting speed 0 मतलब as soon as supply is given. मैंने जो भी बताया अभी just before block code rotor में same thing will happen here. So S equal to 1, resistance is R2 dash is low. R2 dash is low compared to R2 dash by S. Normally S value 0.05 होगा. R2 dash is 0.04, which is equal to 25 times of R2 dash. Meaning, what does it mean here now? Starting में rotor resistance ने 25 times reduce हो गया. तो उस समय क्या होगा? Starting current will be high. So when the starting current is high, then what is happening here? I need to control the starting current. लेकिन क्या है? Torque equation देख लिया ना? So there is a starting torque also. We have to see starting torque. What is happening? Starting torque T start, which is equal to 3 by omega S I starts and R2 dash by S. I starting, we know this formula T into omega, which is a power 3I square R2 by S, which is area of power. We know this, we already done this one. 3 by omega S I square R2 dash by starting torque. So is that the starting torque is really improving? We have to see here now. So mention that point during starting rotor resistance is less. Equivalent to a short circuit condition. Equivalent to a short circuit condition. And the current drawn is 5 to 6 times. Current drawn is 5 to 6 times more than the rated current. 5 to 6 times more than the rated current. ठीक है यार, am I getting the torque here now? Full, I mean more torque current तो ज्यादा है, ठीक है, torque मिल रही है या नहीं देख लेंगे. Starting torque क्या होगा? T start equal to 3 by omega S I start by R2 by S, S equal to 1. Full load torque. So am I really increasing the torque or not? देख रहा हूँ. Current तो increase हो रहा है, लेकिन torque increase हो रहा है या नहीं, उसके हिसाब से I2 dash by S full load. Take the ratio, very important expression exam के लिए. ये दोनों ratio ले लो. T start by T full load, ये दोनों cancel हो जाएगा. I start by starting current, full load square and S full load. What is happening here? मैंने बता रहा हूँ इधर 5 to 6 times current increase हो रहा है normally, तो क्या हो गया? For example, just an example ले रहा हूँ इधर. This is a gate question asked here now. If S full load running condition में slip 0.04 है, if then I start equal to 5 times of I full load, मैंने बताया which is actually happening. starting current 5 times the full load current होगा. Then what is the per unit of starting torque, or what is the starting torque now? अगर आपने ये कैलकुलेट कर दिया तो देखो इधर T start by T full load, I start by I full load. How much is that? 1 by 5 or 5? I start by full 5. Yes, full load, which is equal to full load slip is 0.04. So what is this one here now? T start by T full load, this is 25. So 4 by 100 here now, which is equal to 1. Which means that, have you observed here? The point I want to mention here now, please understand carefully. अगर आपने करंट को 5 times increase कर दिया तो starting torque is just equal to full load torque. हमको ज्यादा करंट नहीं चाहिए. Getting a more current into the machine is a disadvantage. It is create losses. ठीक है, मैंने एक्सेप्ट कर दिया, चलो तो फिर करंट तो आ रहे, एटलीस्ट वो तो डिसएडवांटेज है लॉसेस का वजह से. एटलीस्ट देख लो अगर हमारा टॉर्क इज इंप्रूविंग और नॉट, गेटिंग मोर टॉर्क इज एडवांटेजेस. तो क्या हो रहा है इधर, करंट तो 5 टाइम्स इंक्रीज हो गया लेकिन टॉर्क तो 5 टाइम्स इंक्रीज नहीं हुआ. ये वाला टॉर्क स्टार्टिंग टॉर्क इज जस्ट इक्वल टू फुल लोड टॉर्क. ये बात समझ में आ गया मैं क्या बोल रहा हूँ? करंट तो इंक्रीज हो गया, लॉसेस तो इंक्रीज हो रहे, लेकिन तो टॉर्क है ना उतना इंक्रीज नहीं हो रहा था. तो इसलिए क्या करना है, उसको करंट को कम करना चाहिए. ओके, प्लीज मेंशन दिस पॉइंट हियर नाउ. यू कॉपी दिस वन. इफ S full load 0.04 and I start is 5 times of full load, what is T start? And you can see T start T full load. You copy this one. So I need to reduce the control. I need to control the starting current. So first now, whatever we have discussed, the first method is DOL method, direct online starting, meaning nothing is there, no precautions taken. Direct online starting. So now second method, अगर direct online कर दिया तो this is what happening. Second one, what you are doing, current को reduce करना है. So what should happen here? So let me do that one. Then what is the, first of all, a current 5 to 6 times, what is the equivalent circuit of induction motor, by the way, during starting में equivalent circuit. So इसका behavior is changing from time to time. Starting में अलग गए, running में अलग गए, no load test में अलग गए, block load test में अलग गए. So the behavior of the motor is changing, or equivalent circuit of motor is changing from time to time. Starting में मैंने बता दिया current ज्यादा है. Then normally when the current equal to rated current is, for example, full load current is 100 amps. So what is IM here? Magnetizing current. Magnetizing current is 40 amps. Now during starting, what is happening? Current is becoming 500 amps. So magnetizing current, see, this is actually 40% of full load rated current. So कोर को मैग्नेटाइज करने के लिए 40 एम्प्स है. जब आपने 500 एम्प्स को भेज रहे मशीन के अंदर, उस समय भी इसको 40 एम्प्स ही चाहिए. ऐसा नहीं कि मेरे पास 500 एम्प्स है, इसमें तो 40% लेंगे, ऐसा नहीं है. मेरे को चाहिए, अगर मान लो आपने 100 एम्प्स भेज दो, 60 भेज दो, 30 भेज दो और 40 भेज दो, 50 भेज दो, जितना ही करंट आने दो अंदर, तो मुझे चाहिए 40 एम्प्स मैग्नेटाइज करने के लिए, कोर को मैग्नेटाइज करने के लिए. ठीक है, तो अभी 500 एम्प आ गया ड्यूरिंग स्टार्टिंग में, तो अभी 40 एम्प्स ही चाहिए. So can't I neglect now shunt element now? Since this 40 can be ignored with respect to 500, so the shunt element XM is ignored. So equivalent circuit becomes here now. This I am just ignoring 40 amps. So the current is I starting current R1 JX1 X2 dash. This is R2 dash by S. S equal to 1. ये वाला 1 हो गया. तो अभी for per phase whatever the voltage that you have given here now. So starting current क्या होगा फिर? IS, which is I start, which is equal to V phase upon R1 R2 दोनों सीरीज है. You can add the impedance R1 2 dash plus no, X1 plus X2 dash. This is the starting current that we have given, right? So ये वाला क्वेश्चन 2 बार पूछा है एग्जाम में. So this is actually important for you, starting current. Right, so we need to make sure that this current should be reduced here. आप बता देना इधर देख के, tell me now what are the methods here now. First at least ये करंट को कम करना है. So to reduce the starting current, क्या क्या करना है इधर देखो, न्यूमरेटर एंड डिनोमिनेटर. What can I do? First one, can you please tell me? Somebody can you please tell me क्या कर सकते हैं हमने? Can I reduce the supply voltage? Supply voltage कम करो, न्यूमरेटर को कम करो. So reduce supply voltage. So reduction of the voltage during starting, reduce supply voltage. तो problem क्या होगा यार? Look at here now. What is the problem here now? We have to take care of the torque also. मैंने बता दिया already. You have to take current को reduce कर दिया. For example, current is reduced by x times. इधर क्या voltage reduce कर दिया, तो current x times reduce होगा. Torque क्या होगा? Torque में क्या चल रहेगा? देखो T start by T full load, I start by I full load whole square ये वाला expression आ गया ना. For example, starting current is reduced by x times. For example, this is 1 by 2 IST over here. IST has become, मान लो ये वाला previously 500 amps है, मैंने ऐसा reduce कर दिया ताकि ये वाला 250 amps हो गया. नहीं तो 4 times करो, 1 by 4 कर दिया तो ताकि क्या होगा, ये वाला 500 by 4 which is 125 amps हो गया. ठीक है यार, लेकिन टॉर्क क्या हो रहा है? Please understand the torque here now. T start by, that is x times. I am saying this is x times. T start by T full load. What is happening here now? X IST, it become X IST or X IS starting current, XSC, I full load whole square. Yes, full load. What is the torque reduction here? T start by T full load, which is X square by IST by I full load whole square by X full load. ये क्या हो गया? इधर what is the X here now? X का मतलब क्या होता है इधर? What is the value of X in this case? X is 1 by 4. 1 by 4, तो इधर क्या हो गया? 1 by 4 whole square. So T start by T full load क्या हो गया? 1 by 16. So meaning, if current is reduced by X times, if current is reduced by 4 times, but torque is reduced by 16 times. Do you agree with that? ये बात समझ में आ गई आपको? So, and is it acceptable? पहला चीज क्या है? Is, did you understand this point? मेरा प्रॉब्लम क्या है, इधर ज्यादा करंट है, ज्यादा करंट को कम करना चाहिए, लेकिन आप ये भी देखना चाहिए टॉर्क, स्टार्टिंग टॉर्क ज्यादा कम नहीं होना चाहिए. ये पहला चीज क्या होगा? ठीक है, मैं तो कोशिश कर रहा हूँ करंट रिड्यूस करने के लिए, वोल्टेज को कम कर दिया ताकि आपका करंट रिड्यूस हो जाएगा. मान लो चलो फिर इधर 4 टाइम्स रिडक्शन कर दिया बाय रिड्यूसिंग द वोल्टेज 4 टाइम्स, तो टॉर्क क्या होगा? फ्रॉम दिस फॉर्मूला 1 by 4 whole square, which means 16 times reduction. Do you accept this? I will not accept this one. Torque 16 times reduction is not at all acceptable. So current reduction is x times, torque reduction is x square times. Please mention that point. In this method, current is reduced by x times. Current is reduced by x times. But torque is reduced by x square times. Torque is reduced by x square times. Which is not acceptable. Which is not acceptable. Okay. So what is the next method then? ठीक है यार, एक तो इसको reduce कर दिया, दूसरा चीज क्या कर सकते हैं, इसको increase करो, डिनोमिनेटर को बढ़ाओ ताकि ये वाला करंट कम होगा. ठीक है, डिनोमिनेटर क्या होगा? R1 R2 डैश है, नहीं तो X1 नहीं, X2 डैश है. अभी क्या कर रहा हूँ, R1 X1 है ना, स्टेटर का कंपोनेंट से बाहर ही होगा, रोटर तो अंदर हो जाएगा. सो मैं क्या कर रहा हूँ, इसका वैल्यू को बढ़ा रहा हूँ, R1 X1 को. So what is the next technique here now? Second method is to reduce the starting current is stator impedance starting. We call increase stator impedance. Second technique. Again same thing here. So if current is same formula is applicable, if current is kind of decreased by x times, torque decreased by x square times, which is not acceptable here also. Please mention that point. In this method also, current increased by current decreased by x times, but torque decreased by x square times. So the third one is, so that is not acceptable. Auto transformer switching, auto transformer starting. So इधर क्या कर रहा हूँ, ऑटो ट्रांसफार्मर स्टार्टिंग में क्या कर रहा हूँ, इधर देखो हमने देखा है ऑटो ट्रांसफार्मर. व्हाट इज ऑटो ट्रांसफार्मर? So this is what I have. When I'll take a single phase one, and you have a rotor is here now. State, this is rotor, stator, single phase model. Actually 3 phases I have to draw, but I'm showing single phase. Total voltage is V. I have a X percentage tapping. So what will happen here now? ये वाला voltage है ना, X times V होगा. Voltage is reducing based on number of turns. Then the current is becomes XISC. Current also kind of reduce here now. The starting current is I start. According to KVA balance, what should happen? VIST, which is equal to XV, V into I1, V2 into I2, XV into XISC, VV get cancelled out. What is starting current? Starting current is X square ISC here. Look at this one. So the current is reduced by X square times. What about the torque? Let us see the torque. T start by T full load, and the current transformer के लिए मतलब induction motor के लिए कितना current आ रही? This is XISC. Don't worry about कितना enter हो रही. We don't worry about that. As far as induction motor is concerned, induction motor के लिए ये देखना चाहिए कितना current जा रहा है. लेकिन, but while looking at this one, how much reduction is happening, we have to see here now. So I XISC by and I full load whole square S full load. So T start by T full load I full load S full load, very important. So see here now, the current reduction is X square times and the torque reduction is X square times. This is acceptable, I agree. क्योंकि current अगर मान लो 4 times है, 4 16 times reduce current and torque also reduced by 16 times. That is, I accept that. But ऐसा नहीं कि मतलब current 4 times reduce हो गया, लेकिन torque 16 times हो गया, which is not acceptable. लेकिन problem क्या है वाला? Auto transformer costly है. For example, say 50,000 3-phase auto transformer. लेकिन induction motor cost होगा 10,000 मान लो. 10,000 rupees induction motor को चालू करने के लिए 50,000 auto transformer को use कर रही है. Is it acceptable? अगर आपके पास आई तो यूज करो. खाली इनके लिए स्टार्टिंग के लिए, स्टार्टिंग ऑफ इंडक्शन मोटर के लिए, स्टार्टिंग में करंट कंट्रोल करने के लिए, which is not at all acceptable again as far as the money is concerned. So what needs to be done then? In that case, there is one more technique called, which is a cheaper technique here to reduce the current. Is fourth one is star delta starting. So this is a star delta switch, they say. Correct, Amit. Yeah, it is more costlier method. That's what I am saying. So auto transformer is a costlier method, so which we don't move, which we don't prefer. And you please mention that point also. Current is reduced by X square times, and torque also reduced by X square times. Current is reduced by X square times, and torque also reduced by X square times. Now, what we do, there is star delta starter. So it's a kind of switching what we prefer. Initially, what we do here now, मान लो आपका winding delta में connection है. Initially, normally stator is delta connected. So this is what delta connected. Stator is delta connected. This is what 3-phase, and voltage is here. So इसमें जाने वाला current. This is the current which we are interested. This is मान लो ISC is the current, and the current which is going is √3 times of phase current for delta. Now what we doing here now? This is A, B, C. Here are delta connected points को. What I am doing here now, I'm doing in a star switching, not doing a delta to star equivalent like in the network. We are not doing that. What we are doing is we are converting these impedances of say Z. For example, this is Z and Z. We are converting this into, we're connecting into kind of star, rather I would say. This is a point A, and this is a point B, and this is point C. A and B के बीच में same voltage, we are maintaining the same voltage B. Then what is the voltage across this one? This is Z only, that's what I'm saying. Values are Z, it won't change. What is this voltage? Phase voltage V by √3. Here क्या हो गया? V by Z is equal to ISC. इधर का current क्या हो गया? V by √3 by Z. What is this current here now? I starting current V by √3 by Z. So don't you think this is ISC by √3? Starting current ISC by √3. So meaning initially current is √3 times ISC has reduced to कितना हो गया? ISC by √3. How many times reduction here? How many times it is reduced? The reduction is in fact 3 times. 3 times got reduced. Current is reduced by 3 times. But whatever the torque, let me see here now. T start by T full load. This is what the current, right? Delta 2, this is the sequence. Delta 2 star को convert कर दिया. T start by T full. So this becomes so both you can see here now both the torque and current are reduced by 3 times. Both the torque and current are reduced by 3 times. You can see that. So this is not expensive, but problem क्या है? वो वाला we have a multiple options. 3 times, 4 times, 5 times, करना क्या? 20 times, 30%. Auto transformer, all the options I have. But here in only one option I can reduce only 3 times. If you want to reduce by 2 times, starting current I don't have option. So that is like a auto transform is like iPhone. Star delta is like a China phone. So you don't get all the options with quality, right? But it is cheaper. Star delta switching is cheaper and the काम तो हो जाएगा आपका, ठीक है? This is about the starting of induction motor. Any doubts so far? Okay. So we are left with only one topic in induction motor, which is a speed control of induction motor. So which can be done tomorrow, and we need to solve some gate questions, whatever we have done so far. Right. Is that clear topic? Is this topic clear? Basically, make sure the torque and current are equally reduced. There should not be more reduction in torque because we are interested in the torque maintaining the actual value, constant value. Okay. You see the gate questions. Seventeen questioning. Write down. A star connected. A star connected 12.5 kilowatt 208 volts line, three phase, 60 hertz, 60 hertz squirrel cage induction motor, 60 hertz squirrel cage induction motor has following equivalent circuit parameters. Equivalent circuit parameters per phase. Equivalent circuit parameters per phase. Refer to stator. So what are the values? R1 starting current of this motor, when connected to 80 volt 20 hertz, 80 volt 20 hertz. So voltage is reduced. What is the starting current? Starting current equivalent circuit क्या है? मैंने बता दिया equivalent circuit of induction motor. I have drawn. You remember that just now I have drawn. This is the equivalent circuit. Shunt elements को neglect करना है. This is V phase, but voltage is reduced. I start R1, X1, R2 dash, JX2 dash. Voltage reduce कर दिया, उसके साथ frequency भी reduce कर दिया यार. Frequency reduce कर दिया तो क्या होगा? इसका values भी accordingly reduce होगा. क्यों? X equal to JL omega. So proportional to frequency. So what is the new value here now? So at 60 hertz, X1 equal to X2 dash equal to 0.1. At 20 hertz, how much it will be? This will be 0.4 proportional to frequency hai na? By 60 into 20. So this value will be both 0.136. Now what is the starting current? Starting current is, this is 80 volts, of course line voltage, that is all values given are line voltages. So 80 by root 3 under root R1 plus R2 dash, R1 plus R2 dash, 0.3, 0.3 whole square plus X1 plus X2 dash whole square. Matlab this is the one, new value. That's all. Let me this value. Let's do it. The value is around 70. That's perfect. 70.1. Yeah, 1 amp. Others, what about others doing? Second question. 16 question, eh? The starting line current of 450 volts 3-phase delta connected induction motor is 120 amp. Is 120 amp if rated voltage is applied. If rated voltage is applied. What is the starting line current at reduced voltage? What is the starting current at reduced voltage? 110 volts. कुछ नहीं यार, इस डेल्टा कनेक्टेड दिया 120 एम्प से 450 अप्लाई कर दिया था. आई नो स्टार्टिंग करंट समझ गए ना बात. 415 अप्लाई कर दिया तो 120 आया, 110 अप्लाई कर दिया तो स्टार्टिंग करंट कितना आएगा. स्टार्टिंग करंट का फॉर्मूला दिस इज द वन. दिस इज द वन. ठीक है, तो बी फेज मतलब स्टार्टिंग करंट इज प्रोपोर्शनल टू वोल्टेज. लेट इट बी लाइन वोल्टेज और फेज वोल्टेज, क्योंकि दोनों डेल्टा साइड है ना. So current is proportional to voltage. So what will happen here now? 415 by 110. So 120 by x. 415 के लिए 110 है, 110 के लिए 120, 110 के लिए कितना है बस. That's all. 120 into 110 by 415. What is this current? That's all. Simple question. Yeah, that's correct. 31 amps. Another question is, per phase equivalent circuit of of 2-pole 3-phase 50 Hertz induction motor is given below. Is given below. And slip is 0.05. Voltage across the magnetizing reactance Vg. This is given voltage across this one. Vg is given as 210 volts. Find the torque. So this is the rotary equivalent. I want the torque. I know torque into omega, which is equal to power. Power kaha hai? Power is here. 3 into I2 dash. This is the power I know. I2 dash. 3 I2 dash whole square. Remember we have obtained 3 I2 dash whole square R2 by S. So that's a mechanical power, I would say. What is I2 dash here? ये वाला current. Node voltage पता है. Nodal analysis में आज ही कर दिया हमने. Node voltage 210 नहीं, from here to here. So voltage across is also same. So what is this value? R2 0.05 by S. 0.05 by S equal to 0.05. It is 1. So what is I2 dash? Only magnitude चाहिए. I2 dash is equal to voltage is 210 square root of 1 square. This is 1 square plus 0.22 whole square. Get me this value. And R2 dash by S. Substitute karo. And omega. Omega is, I know omega equal to 2 pi n by 60. But how do you get n? N equal to 1 minus S into ns. This we know the formula. So 1 minus S into 0.05 ns. How do you get the ns? From this data you can get it. ns equal to 120 F by P. 120 50 P, this one, this is 3000. So 3000, get me this. So you substitute everything. I2 dash आएगा इधर से R2 dash by S. I know this value, which is 1. Omega is this 2 by n. N, once you get the n, substitute n, get the omega, and get me the torque here finally. Solve this one, please. Current you should get around 205 amps. Speed is around 2850, and you substitute this. This is 1. Torque around 401. Please verify this. Next one is write down. It's a gate 14 problem. The 3-phase 50 Hertz 6-pole induction motor. 3-phase 50 Hertz 6-pole induction motor has rotor resistance and rotor reactance. Rotor resistance 0.1, rotor reactance 0.92 ohm. Neglect the voltage drop in stator. Neglect the voltage drop in stator. And full load slip is 0.03. Full load slip is 0.03. Ratio of maximum torque to full load torque. Ratio of maximum torque to full load torque. We have seen this one, ratio of maximum torque to full load torque, but we have seen, if you look at the problem, I think full load torque to maximum torque. Look at our formula. Is this the one we have talked about? S full load by S max. S max by S full load. Can you see that one? ये वाला ratio चाहिए. This is the formula I told you. Can you please refer that one once? लेकिन S max कैसे आएगा? S max मिलेगा only stator impedance neglect कर दिया, तो only rotor circuit is considered. So R2 and X2 only rotor. So R2 equal to SX2. So S equal to R2 by X2. That is S max. Maximum power transfer theorem we have used already. So means S max कितना है? X max आएगा R2 by X2. 0.1 upon 0.92. So get this value, substitute here. S full load is given. Get me the ratio T full load by T max. No, ratio is asked, ratio of maximum torque to full load torque. We want T maximum by T full load. What is this value? Oscar, how is that maximum by full load चाहिए ना? So maximum by full load, maximum will be more than full load, right? It will be more than one. The formula that I used is full load by maximum के लिए ये वाला. पूछा क्या maximum by full load? What is this value? Tell me first of all. 0.1 by 0.92. ये कितना आ रहा है बताओ? We'll validate this one. What is this value? Point 1 by 1 by 0.1 by 0.92. It is 0.18. Huh? Now why 1.8? Rohit, it's a 0.18, right? 0.108. Fine. So substitute करो ये वाला. Yes, full load is 0.03. That's all. You get this value. Take the ratio. You calculate this, take the ratio, and the ratio को उल्टा ले लो बस, because that is being asked. हम जो भी कैलकुलेट कर दिए फुल लोड टू मैक्सिमम है, लेकिन हमको चाहिए मैक्सिमम टू फुल लोड चाहिए. Rohit, are you saying that maximum to full load is 0.51? Rohit, are you saying that maximum ज्यादा होना चाहिए ना full load से? I think that's a T full load by T max calculate कर दिया. This is probably the one 0.5156. So आप ये उल्टा ले लो 1 by 0.5156. ये कितना आ रहा है? I think yeah, you have to take reverse of that, something around 2, 1.95, something around that. So this is your answer. Okay, anyway, it is 1.95. So do this one last problem yourself. Right pole, 3-phase, 50 Hertz induction motor. Write down a 8-pole 3-phase 50 Hz induction motor is operating at a speed of 700 RPM. Frequency of rotor current. Frequency of rotor currents in Hertz is, please do this yourself. Frequency is F2 equal to SF. So please do this one. I'm expecting an answer from you after solving all these problems. So any issue here? So it's simple, right? Frequency of rotor currents F2 equal to SF. F is 50 Hertz is there, S calculate करना. S is ns minus n by ns. n तो पता है स्पीड कितना स्पीड में जा रहे 700. ns चाहिए. ns is 120 f by p. 8 poles. How much is this? 750. RPM. So this is 750. So calculate this. That's all. Bhaskar, you're saying 0.066. Okay. Sleep by na? That's what you are saying. Sleep is 750, 750 by.
Yes, sir.
Okay, 50 by 750. Equip it as such. Matlab 1 it cancels out 1 by 15. So to get the accurate value. Yeah, that's correct. Whatever you said. But I'm just keeping that 1 by 15 into now f is 50. That is the final answer. Yeah, that's perfect. So means stator is having 50 Hertz currents, rotor is having 3.3 Hertz current. So primary has 50 Hertz, secondary has 3 Hertz. So it's a different frequency operation. Whereas in transformer, primary same frequency and secondary same frequency. We have both primary and secondary has same frequency. Okay. Okay, then I'll stop here. Tomorrow induction motor will be done. And then first half an hour and let us see then single phase induction motor. I'll start some gate questions. Okay, by I think not tomorrow, day after tomorrow, day after tomorrow, 24th. Huh? I think it should be done. I don't think by 25th we can. 23rd, 24th. Let us see if anything pending. 25th, I'll see. Okay then. Thank you guys. And tomorrow 3 phase will be done. Thanks, Bhaskar, Rohit, and Mishra. Sahu today is silent. Rohit.